you hear me? Okay, cool. So, thanks for coming. Thanks, Seldon, for inviting me and giving me the opportunity to share my experience with you today. So, I'm Gema. I work for BBVA, it's a Spanish leading bank. I'm part of the research laboratory in the Artificial Intelligence division. And this is my Twitter handle and GitHub handle. So today we are going to dig into different things. I'm going to explain you the big picture of what are we going to see. I'm going to roughly share with you my experience on the TensorFlow Dev Summit from this year in San Francisco, which I was able to attend, and also what's new on TensorFlow 2.0. And we are going through an experiment that we are predicting the credit card operations for mainly getting better with our infrastructure in the bank, and we are going to see the results. So how many of you are using TensorFlow every day? Cool. Keras API maybe? Who is like dealing with graphs? Okay, nice. So today, mostly what we are going to be digging in is with a sequence problem. We're going to see how we're going to measure the performance in between like TensorFlow, the stable version of TensorFlow that we've been working with, that is like 1.13, and TensorFlow 2.0. And we're going to see which metrics and how do we do it. So, what's new with the TensorFlow 2.0? So the thing is, like, TensorFlow was born as a deep learning library, mostly like a graph-oriented operation-based, and it has been evolving until wanting to understand how all the machine learning lifecycle works, from training to deployment. In the training area, we do have like input pipelines with TF data. We do have like now a library with pre-trained and models that are moving into the TensorFlow Dev. And then we have like the pre-made estimators and keras who are like dealing with models. For the distribution strategy, that is like mostly about the scaling up. We do have like, we can run it in a machine, a CPU, a GPU, or TPU. So the new TensorFlow 2.0 comes with the TF function that is mainly changing how your graph is going to work, and it's going to be like the new Pythonic way to run TensorFlow. This is going to be saved into the, as we know, the safe model, and deployed with several, like with TensorFlow Serving, with TensorFlow Lite, or in the browser with GAs. So, what's new? What's the big thing in TensorFlow 2.0? Is that the session, do you remind, like when you build your model, set your variables, your placeholders, and then you give like that all the thing, and then you have to start like the session run, in which you have to feed a dictionary with the data. So that no longer has happened. That was like known as the kitchen sink strategy, in which you, at the end of the design, you have to really know and test if it was working. So they have removed like the session run, and they have like go like to strictly to the eager execution, and remove mostly of the graph collection functions. Besides, open source has like some setbacks, as there are a lot of duplicates, mostly with the TF contrib layer. So they are removing like a lot of things that are like duplicating like the functionalities. And besides, how the variables are tracked are also changing and are no longer initialized. But that doesn't mean that you don't have to track them. It means that you don't have to set them in the first place. So mainly what I want to tell you about this and what you should know about TensorFlow 2.0 is like the paradigm of programming is going to change significantly. Okay. So there's a thing about this that TensorFlow started as a deep learning library, but they have they are adding like more machine learning areas that should be like implemented. One of the one that I'm working now is TF agents. There are like TensorFlow for reinforcement learning. There's also like a very interesting and tough TF probability library in which you can like know more about the probabilistic of your deep learning models and know more about your knowns and unknowns, and it's quite cool. Besides, there has been like a scalable step towards TensorFlow federated. That means that machine learning models can be like trained independently, but in various devices. Meaning that, for example, in your mobiles, you do have like pictures of your dogs, and then there is like one model on the cloud that is going to use or can use your pictures to train one model. So the data is going to be like separated for the model and be used like in one model is going to be like used for training with data in various devices. Besides, the one of you that are working with images and have like those like sequence problem images that they have like different variable length, you do have like a new type that is like the TensorFlow reg tensor type that is going to solve problems that are like settled with with images and related with sequence. So keras is one API to rule them all. Okay, it's cool because you can use it like straight ahead, and you can build a model in a few lines of code. And mostly, what they are like introducing here is like a few methods that are going to be used for the model. And besides introducing the keras row ops and the debugging mode, you have like now in the API strictly like methods that are going to be used for the model instead. But there is a problem. If you have like worked with keras, you have like that kind of a problem, the out of the menu thing. Meaning that you have like those, you build layers, you put your parameters in, your optimizers, but that's not really flexible. You can only like build like what it's done, or maybe like vanilla architectures or stack architectures, but you cannot like design in a high level model. So this problem has been with keras for a while, and they have introduced like TF function that is mainly a Python decorator that helps you with that. So imagine that you are building like a convolutional neural network that has like several layers, and you want to add your own optimizer, like that you have made an optimizer to that architecture. So you can use actually like keras and introduce that optimizer into your architecture. So the only thing that you might have in mind is that you have to put the decorator first before actually like adding or defining the new operation. So under the hood, what TF function does is to kind of transform your Python code into a optimized version for C for the graph. So at the end, it's like a way of transforming your code into an eager execution. And now the examples that are out there mostly are used for distribution over TPUs, GPUs, and TPUs, but you can use it for many things. The TensorFlow team claimed that there was like a 10x speed up in small nets. We have like been doing experiments to test if that was true or that wasn't. Besides that, we are talking like that flexibility at a high level to go out of the menu, but using keras. We do have like the autograph The autograph, it's a Python compiler code that rewrites the TensorFlow expressions. So I don't know if you have been like following the product, but in one time they started to put like TF while loops, TF4 loops, so you could like iterate like in the graph for your desired operations. That's no longer available, and where it's going to be, the autograph is going to take all of that. So now what the autograph is supporting is like if, while, for, break and continue operations, some assertions that could be like useful for testing, and they plan to support lambda functions, which is like cool because it's, at the end, is like quite Pythonic. So if you have like one or two ideas that, if I have like to tell you like two ideas to take from TensorFlow 2.0, it's like the graph is going to die because it's going to be put under the hood, okay? And if you want to really build with the graph or think in the graph, you should use the decorator, okay? And also the autograph is going to speed up like quite a bit. So what's our business problem? Here we use like machine learning for a lot of things. We use machine learning for traditional banking problems like fraud detection, like money laundering. But this experiment that I have like brought to you, it's like different. We wanted to go like out of the box somehow to show you that we can like use machine learning also for optimize our infrastructure, and that's what we want to do. So mainly what we have like when we start like measuring operations, we have like periods in which we do have like a lot of operations, okay? Maybe in between like 12 and 2, we have a lot. In between 4 and 6, we have a lot. But during that, we have nothing. Or during like another times, we do have nothing. So in the end, we want to optimize our machines to be able to be prepared to deal with those operations when they need, okay? So for this experiment, we're talking about like 700,000, which is like good to start, but we, you know, like we're in the bank, like for a normal project, we deal with 900 million. So for this, for us, it's like a prototype, like a quick prototype, okay, which is good for starting to deploy like some machine learning and deep learning, but not enough for a real like production project. Our goal here was like mainly like make a quick test and see how it works. So we have been working with the aggregate samples for 1 minute per day. So we do have our own platform for data ingestion and for our pipelines, but for here we wanted to also like use the cloud. So what we did, it was like we would use like the PySpark and then the Flow model, and we were using like mainly part of the data set that we wanted, not all. We use like the amount, we use like all the date timestamp that we were using, and we were using like those aggregations that I told you about, that window that count the number of operations in a given time frame. We also did like some normalization in order to speed up like training and how it works. So from this, if you are never using like the cloud, please use the same region and zone for ingesting the data and running the job, okay? Because if not, it's going to be much more expensive and much more frustrating, okay? So before going into the deep learning model, we actually like run first early exploration on early benchmark with other kind of models that can like help us to know what is going on. So we will use like the vanilla Python, like the simple moving average, the latest value, a random one. We have been also like testing a tool from Facebook open source, and it's called Prophet, that actually it has been used to define the Facebook likes of your pages. We do use like also like Arena, like the like normal like standard one, and we use also like Timecode, which is our internal tool that gave us like the whole winter and some LSTM like first approach, like the vanilla with a vanilla architecture. So who knows what an LSTM model is? Cool. Okay. So recurrent neural networks are a kind of architecture of kind of a neural network architecture that is like dealing with the sequence problems. Okay. Besides, there are like several types. LSTM model is especially thought about for the vanishing gradient problem, and it has like the special requirements to be fed by the cell type and the hidden state, and then he has like the cell has some kind of three different gates that are like dealing with the information. They have like a forget gate, which doesn't like deal with the learn position, the input gate, and the output gate. What I wanted to get you about this is there is a specific architecture for dealing with sequential problems that might require, let's say, certain kind of memory. This is not the state of the art, okay, because the state of the art has moved into the transformer, and it's now like more like this. But we wanted to test how this works. So we have like tasted two different kind of architectures. In one half, we test the vanilla one, that it's like with one layer of LSTM plus a dense layer, and we also like use like stack architecture that is using basically two layers of LSTM with a dropout that actually like making like the training faster, and we are using in the end like we are like training like 30,000 parameters more or less. Going into the TensorFlow 2.0 code and the TensorFlow 1.13 code, it's exactly the same, okay? So you could use your TensorFlow 1.13, which is like the stable version we have been like working with, and the TensorFlow 2.0. In our case, what we have like done is like put also like the TF function for doing some things. I will tell you later. But actually, this is like how we have defined the stack architecture. So we have like the model in which we call like the sequential TF keras, and we do have like the first layer of LSTM, we have the dropout, and the second layer. The only difference in code with the vanilla architecture might be like this line, in which being the stack architecture, we have the return the sequence to be retrained in the second layer of LSTM. Okay, so we do have like the compile model. You can print a summary to see the parameters, and then we do have like the callbacks. We use like the callbacks pretty much, okay, because like they give you like neural networks are like black boxes, and it happens a lot, but like some callbacks are like flashlights for that and allows us to know like a lot. So in this case, we're like calling to a version of Tensor Flow that it's like related with the timestamp of the model, and then we do the fit with the data, the batch size, and calling like the callbacks. Okay. So from here to the model code, but there's more than the model code when you do a machine learning program, okay? So you have to read the data. You mostly have to make like a conversion, in our case related with timestamps. You do a normalizer, And normally you do a split in between like the training test and the test test. You can do also like validation tests. Here for the sequence problems, we have been dealing with sliding windows, and also like at the end we do a function that is going to help us like calculate what we want. That is like the error we're going to measure, mostly the mean square error. So which global variables and arguments are we using for our model? We are using a global seed that is going to help us with the reproducibility and also the batch size. We're going to split in between like different dates, and we're going, as an argument, so we're going to pass the epochs that we're going to be learning the model, the sequence length, and the future length. Why do I put you this slide now? Because these are the parameters that are going to be changing in the model, because when we when we launch a model, we launch about 500 models, okay, with different parameters. And from that, like, we choose the better, and we go from there, and we launch under 500 models, okay? So having like a benchmark in between, you can like set how hyperparameters work. You can actually like get more control of the problem. Of course, yeah. 5 minutes, cool. So how do we measure performance? So we have like been setting a virtual environment. Please, if you are testing TensorFlow 2.0, use a virtual environment, okay? Because there are like no conflicting like versions with all your libraries. We have like setting the reproducibility seed. We have made like unit tests and timing and cognitive metrics. In case of sequences, we don't measure accuracy, which is like the normal thing to do in a TensorFlow model. We are like very interested about the error. So our thing is like, it is getting right, but what we don't want is like, it is not getting wrong so much, okay? So what we measure is like, it doesn't get wrong in the future. For the seed, okay, this took us a while, so that's why I brought it here. If you're working with the 2.0, please work with the version 2, stable version for the seed. That will help you to launch your experiments faster. And if you're doing with keras, remember that you have actually to set up the session configuration first, because you don't have like a random seed in keras for reproducibility. Unit test. Okay, so BBVA is betting on not using notebooks. I'm sorry for the notebooks fans. And we are like more getting into how data problems should be used in case of software development. Okay? So if you so testing is a very important part of software development, and we are using like unit tests for this case. But if you are like in the data scientist thing, you can use like TF assert, you can use like the pandas assert method, and you can use also like the NumPy has like a part for testing. So I was a fan of notebooks because the notebooks like could like get me how things were working, but notebooks are not secure, okay? Notebooks are hard to put into production, are great for prototyping, but hard to get into it. So in the end, what we do is use the Python unit test case class, in which we're going to define like some assert equal assumptions. It's going to be like, okay, one of the things that I always do with notebooks is to see like the dimensions of my models are working properly. Okay, so we can assert equal with that. Another thing that we need to test is if the error, the mean squared error that we are using, is equal in the several models that I'm betting with the same seed. So we use like assert almost equal for that. As we have said before, we use like sliding windows to see how well are doing, like not only like in a given time, but in the future. So the results. So actually, what they said, what TensorFlow 2.0 says, it's true. because we tested like the TensorFlow 1.13 and how was it working. And actually, TensorFlow 0.0 was like not the half, but maybe like a 40% like less time in training. Okay, it was like that's great. And also like the error test that was like given was less. So yeah, there is like a better performance or eager performance in TensorFlow 2.0 in the same conditions with the same like reproducibility problems. There is. We we don't think it's a 10 plus, okay? But it gets like most will have, which is like quite cool because the stable version of TensorFlow 2.0 will be released this spring. So this is the sliding window is great because it lets you measure how the error is increasing in the future. So the best model for us was not the one who was predicting how well was doing in a given time, but how was the evolution of the error in the model. So here we can see like the performance from TensorFlow to keras like was significantly better because the error was like was much more less. And this is actually how we have measured all the problem and all the experiment. So here, this is a day of these are 3 days of our operations in the bank. Okay, this is what I told you about the how we have like more operations in a given time of the day. So the orange line actually is like the predicted line, and the blue one is like the reality. So in here, like what's happening is like the one we have more operations, like midday, was significantly better, and that's why we use like this model. In the down graphic, you can see the relative error. So once the relative error went less than +1 relatively, we didn't want was like not really optimal for us. So here you can compare like this is the relative error and the operations count. So this is how we choose models like with these two graphics and having like into account how the operations predicted and the error works together. Okay, this is like really important to measure in pairs, like metrics in pairs. So yeah, so that's it. I hope you enjoy. And well, I will be like here during the event and after. So please feel free to reach me with any details that you want to know about the alpha or wherever you might need. So thanks.
Q&A. Anyone got any questions for Gemma? Did anyone expect that they would be releasing 500 models at a time? Yep. Yeah. That's a pretty good number.
Well, let us take a microphone.
Lee's going to give him a microphone.
How do you deal with the seasonality in your data?
Sorry?
The seasonality.
Seasonality.
Seasonality, yeah.
Yeah. So yeah, it depends really on the problem, but we mostly work with weeks, and we take like special weeks like in groups, in and out. For example, normally we make a data set of weeks in which we get out Christmas and special weeks that are like holiday ones, and then we make like special data sets for those seasonalities. So yeah, and then we have like another approach that is by days, okay, in which we handle like from Monday to Friday, no, from Monday to Thursday, and from Friday to Sunday.
Do you use Sarima or?
We have done the ARIMA like models, but we do mostly as performance benchmarking because it depends on the problem that you want to solve. But in this case, we wanted to solve how the evolution of the model was in the future. So how could predict like the model like the count of operations from weeks and beyond. Thank you.
It's your name and where you're from as well. Thanks.
Hi.
Thanks for the talk. Why do you think there is a difference in error, in the predicted error between TensorFlow 1 and TensorFlow 2? Is it because of the different models, or?
I think they should be like the same because the seed is set as the same. I want to think that it's because it has like better performance. Until now, it's happening in all TensorFlow 2.0 models. So the training error is like lower than the 1.13. Yeah. That's why we were talking about the seed, because the seed was like key to determine, to measure actually the errors.
How do you, because the deep learning is like kind of black box kind of stuff, how do you explain explainability of your model?
Yeah, so there are like some areas in the bank in which we must have explainability. Then we can use deep learning. So we use regressions, we use another things. We use trees because trees has like some explainability things that you can do. But we can use like deep learning for anything else, like customer discovery, like better optimizing our infrastructure. Does it like answer your question? Yeah? If not, we can like follow up later. Okay?
John Davis from SD mentioned the regional models. I wondered how they compared with deep learning models you were discussing performance-wise.
Sorry?
You mentioned arena models and type of
Yeah.
more traditional.
So what happened with that, ARIMA were like much more better in the long term and much more worse in the, much more better in the short term and much worse in the long term. So if you want to predict the next operation in that day, it was like better the ARIMA and the traditional approach. But as you went in the future, it were worse. It was worse. Oh my God.
Just related, what about profit, and when you say in the future, how long in the future the work?
Yeah, so that's actually a parameter that we set up that is called the future leap. So you can run a model, and the model we have like made the software in which you can actually like put as a parameter the future leap. Its number for the future leaps is like has to be like 1 minute because it's like a sequence.
So at which point the ARIMA was getting worse than the
So we have like, yeah, so it depends on the, actually on the, in the first row until like the, from the next day, it was like getting worse. But that day was like really better in the ARIMA. That's it, yeah? Yeah, cool.
Cool. All right, good stuff. Let's give another round of applause.